In this video, I'm gonna do extra practice 4 in tutorial 2. Notice that I'm not doing extra practice 3. I'm not doing this question. The reason is that in order to do this question, you need to understand the proving technique contradiction. But you guys haven't done that yet, that's why I'm not doing it. Well, after you guys learn contradiction, we'll come back to this question and I'll do it after that, okay? Because I feel like it makes no sense to teach you this since you guys don't know anything about contradiction. We will come back to this question. But in this video, I'm gonna do number 4. So prove that if A minus C equals to B minus C and A intersect C equals to B intersect C, then we have A is a subset of B. And they ask you, is A equals to B? So let's do the first part. We want to show that A is a subset of B. In order to show one set is a subset of another set, we need to pick an arbitrary element from A and show that this element is also in B. So let's let X be an element of A. And we want to show X is also an element of B. So this is what we need to show. We know this, we need to show this. Alright? Now, if you go back to the question itself, we have 3 different sets. We know X is in A. We want to show it's also in B. But do we know anything about C? Do we know if X is in C or not? We don't, okay? We don't know anything. So that means we have 2 different cases. Our X is either in C or not in C. So the first case is, suppose X is in C. Well, if X is in C, we know that X is in A, and we know that X is in C. That means our X is in A intersect C. So we know X is in A, and X is in C, which means X is in A intersect C. Alright? Then we know that A intersects C equals to B intersects C. Okay? Since A intersects C equals to B intersects C, that means our X is also in B intersects C. Well, if we know this, that means X must be in B. Why is that? Because X is in B intersects C implies X is in B and X is in C. So we know that X is in B. So in this case, if our X is in C, we know that A is a subset of B. The second case is our X is not in C. So suppose X is not in C. Then we have X is in A, X is in A, and X is not in C. That means X is in A minus C. Okay? We know that A minus C equals to B minus C. That means our X is also in B minus C. Well, if X is in B minus C, that means X is in B, but not C. Okay, so in either case, we have X is in B, which means A is a subset of B. Okay, so that's the first part. The second part is A equals to B. Well, we showed that A is a subset of B already. If this is true, that means B is also a subset of A. Okay? If that's true, then B is also a subset of A. So first of all, we need to decide if it's true first. Okay, this is the same as asking, is B a subset of A? Alright. Okay, so in order to decide if it's true or false, let me draw a diagram. Let's say this is my A. Oops. This is my A. We know that A is a subset of B, so let me draw a bigger circle. Let's say this is B. Oops. This is B. Okay, and we have another set. We have another set, and let's call it C. We know that A minus C, which is this part, has to be equal to B minus C, which is this part. So well, right now this is bigger already, so well, I'm guessing that B is also a subset of A. Okay, otherwise looks like doesn't make sense. I would say it's pretty obvious that they are equal. When we prove it, it's kind of like you can use the same logic for B. Because why is that? Because just ignore this, ignore what's given here, then A is a subset of B. The condition that's given here, it doesn't matter if we have A or B here. So even if you switch A and B position, it's the same thing. So if A is a subset of B, then B must be a subset of A. So that's what I'm thinking. Let me just repeat what I just said, because when I see this question, I know this is true. By knowing this is true, I know exactly this is true. The reason is that even if you switch the position of A and B, it's the same. So none of the condition make A or B special. So A and B, even if you switch them, you get the same condition. So they're not special from each other. So I'm guessing they're the same thing. I don't know if you got my logic. That's not a formal proof, but when I see this, that's what I think. So I'm gonna say, well, yes, this is a subset of A. Then let me try to prove it, okay? It's basically the same thing. So it's basically the same thing, and I don't even want to write it. Okay, let X be an element of B, and you want to show X is also an element of A. It's basically the same thing, but you change A to B, B to A. So copy and paste. Alright, let's just make some changes. Again, you suppose X is an element of C, and you change A to B here. That's gonna be B as well. So X is in B and X is in C, so X is in B intersects C. Since A intersects C equals to B intersects C, that means, so you change all the B to A and change all the A to B. And that's gonna give you the proof, because it's literally the same thing. Okay, so here you change all the A to B, 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 and you change B to A, A. Okay, and in either case, copy, paste. In either case, we have B is a subset of A. Therefore, A equals to B. And that's it.